All right, pre-algebra students, today we are moving on to our final lesson of Module 1. We are ordering real numbers. So to be successful today, we should be able to compare real numbers and arrange sets of real numbers in ascending and descending order. That means increasing or decreasing order. So in this lesson specifically, we will talk about comparing real numbers, ordering real numbers, and converting numbers to alternate forms. For example, from decimals to fractions, fractions to decimals, decimals to percents, and so on. To be successful, I recommend using your guided notes for this, as well as some sort of scientific calculator. So let's get started. So when we talk about comparing numbers, when we usually compare numbers, we're using inequality signs like the less than symbol. The arrow pointing to the left is the less than symbol. And the greater than symbol, or the symbol pointing to the right. So let's just practice with comparing some values here using inequality symbols. So we're saying 2 is compared to the square root of 8 in some way. And for this lesson, I recommend that we supplement with a scientific calculator. For us, that could be desmos.com/scientific. So we don't really know the square root of 8. 8 is a non-perfect square, so we can estimate this. So I'll just type in the square root of 8. And if I round to the nearest tenth, that's about 2.8. So 2.8 compared to 2. So I think 2.8 is greater than 2. So I'm going to use so 2 is less than the square root of 8. The arrow in the inequality symbol is always going to point towards the smaller number, and it's going to open up towards the bigger number. So we can say 2 is less than square root of 8. Moving on to B, negative 1.5 compared to negative 5 over 2. Now if I convert negative 5 over 2 to a decimal, if I divide 5 by 2, I'm going to get negative 2.5. And I know for sure that the farther away you are from 0, when we talk about negative numbers, the farther away we are from 0, the smaller the number gets. So I'm going to say that negative 1.5 is actually greater than negative 2.5. And C, 12.5 compared to the square root of 145. Let's pull up our scientific calculator one more time. And we're going to type in the square root of 145. I know the square root of 144 is 12, so the square root of 145 is pretty darn close. It's about 12.04. So approximately 12.04. And I know that 12.5 is greater than that. 12.5 is greater than the square root of 145. Now let's talk about ordering real numbers. Lists of values can be ordered from least to greatest or greatest to least. So we are going to list some key words and phrases that can be used instead of least to greatest or greatest to least. Off the top of my head, when I think of least to greatest, I can think of ascending, meaning the numbers are climbing. And I can think of increasing. These are two common ways to say from least to greatest. And from greatest to least, we can say descending, kind of like descending down a flight of stairs or down a mountain. We're decreasing. So these are just some key words to keep in mind when we are ordering real numbers. When we compare and order real numbers, it is extremely helpful to first represent the values in the same form. For us, it's probably going to be most convenient to convert fractions and percents to decimals. So let's just quickly go through how to do that. So, fractions. Let's say I have the fraction 1/3. Remember, that's just saying 1 divided by 3. 1 divided by 3 is going to be 0.3 repeating. That means the place value 3 is going to be repeating infinitely. And if we write this as a percent, remember to convert decimals to percents, you are moving the decimal 2 places to the right or multiplying by 100. So this would be 33.3 repeating percent. Let's do one more. The decimal 0.2, this is really 2/10. And if we reduce 2/10, if we divide the numerator and denominator by 2, you would actually get the fraction 1/5. And as a percent, if you move the decimal place on 0.2 twice to the right, you get 20%. You can feel free to fill in this table and check your answers with me. It's really helpful to practice converting numbers to alternate forms for this activity. So let's do a little bit more comparing real numbers practice. We're going to fill in the inequality symbol that best describes the relationship between these two numbers. So looking at number 1, we're comparing -7/8 to -0.5. Now I need to divide 7 by 8 to find the decimal for 7/8. We can use long division, but we can also supplement with a scientific calculator in this lesson. We should still know how to divide these two numbers here, but 7 divided by 8 would give us 0.875. And since this is negative, it would be negative 0.875. Now when we compare this decimal to negative 0.5, we see that if we were to place these numbers on a number line, negative 0.875 would be farther away from 0, which means it is a smaller number. So negative 7/8 is less than negative 0.5. Now let's compare pi squared to the square root of 50. Now let's just type this in here. If we did pi squared, 3.14 and then infinite digits after that squared is about 9.9 if I round. So about 9.9. And if I did the same thing, if I estimated the square root of 50 to the nearest tenth, square root of 50, I know that, yeah, that's going to be very close to 7 because we know the square root of 49 is 7. So this is about 7.1. So now that we've converted both numbers to the same form, both to decimals, now we can compare their values. And I know that 9.9 is greater than 7.1. For additional practice, I recommend trying out problems 3 through 5. All right, now let's practice ordering real numbers. So number 6 says list the following in descending order. Descending means from greatest to least. We're starting at the top and working our way down. So what I want to do is I want to write all of these values as decimals. That's what I usually lean to. You could convert them all to fractions, but that seems like it would be a little bit more difficult for us. So first off, the square root of 121, the principal root of 121, that's 11. That's saying that the number that when you multiply it by itself twice equals 21, that number is 11. pi squared, we already said, was approximately 9.9. 11.1 is already a decimal. And if we estimate the square root of 130, we get approximately 11.4. Approximately 11.4. Now we need to list them in descending order from greatest to least. So I see that the square root of 130 is the greatest. That's about 11.4. That is our greatest number here. So square root of 130. Then we have 11.1. 11.1 is greater than 11. Next we have the square root of 121. And last but not least, we have pi squared. Let's try another one. For 8, it says list the values from least to greatest. That means ascending order. We are working our way from the smallest to the largest number. Negative 5.025 is already a decimal. I don't need to mess with that. The negative square root of 25. Well, I know the square root of 25 is 5, and then we just need to make it negative. This is negative 5. Negative 5 1/5. If I convert 1/5 to a decimal, if I divide 1 by 5, this would be negative 5.2. And negative 11 over 2. If I divide 11 by 2, I get 5.5, and this is negative 5.5. So if I list these numbers from least to greatest, that means technically the number farthest from 0 on this number line is going to go first. And the negative number that is smallest is negative 5.5, or a negative 11 halves. Then we have negative 5 1/5. The next least number would be negative 5.025. And last is the negative square root of 25. And there you go. If you'd like additional practice, we have numbers 7, 9, and then 10 through 12 for ordering real numbers. So that was our lesson. Thank you so much for watching. Make sure that you are trying out the additional practice problems to feel more prepared and successful. And then you can check your answers with my filled in notes in our class notebook. You can just go to Content Library and Module 1 Notes, and it should be right there. Please make sure you're asking for support in the Math Help Desk if you need it, and I hope you have a great day.